So thank you everyone for staying here with me. And first of all, I would like to say thank you to the team for this opportunity. And during this, I think 2 hours, maybe we're gonna talk more about the more analysis and something about this specifically top. So part of this time is I will explain more about some theoretic concepts, and after that, more practical stuffs. And I would like to invite you, if you have some virtual machine, a Linux virtual machine, of course, or Kali Linux or ParrotOS or Debian or CentOS or whatever, if you'd like to open your virtual machine during this workshop together with me, so it sounds great. And because I will explain, I will show something, and if you would like to, take some comments with me, it should be nice, okay? So let me share here my screen with you once again. And by the way, if you made some question, for example, you can take this question because I'm looking in my right side here, in my right side. I have another monitoring, so if you have any questions, so you can take in this way, and I can answer your questions, okay, during this presentation. So let me share here my screen. Okay. Nice. Can you see my screen? I think you can see, right?
We can, thank you.
Nice. Okay, so let's talk about this. This is the title of this topic. It's a second compare different binaries tomorrow analysis, because we have a different binaries to analyze. This is my contact on Twitter at Filipi. And if you have others informations about me, you can find here in my webpage. I have here some talks that I've been participating in different events in Portuguese language and Spanish and English, and different topics about the malware analysis, malware hunting, threat hunting. Maybe you are thinking, what is malware hunting? It's a different approach that I've been using in different conferences. It's very nice. And my Twitter once again, and my GitHub, you can find there different articles and tests that I've been performing in different security sensors. You can inspire you with using this in your environment, for example, and my LinkedIn, if you'd like to, exchange some knowledge with me. Okay, let me introduce myself. I'm security researcher at Senha Segura. Senha Segura, it's a global company responsible to provide some PAN products, privileged access management. It's a kind of acronym, but I'm security research. The focus is just to understand how the attacker using this different techniques to explore all those environments, as we can see. I'm advocate of the hack is not a crime. It's very, very nice project. The idea behind of this project is to talk more about the hacking, the concept of the hacking. So how is the creative mind of the hacking? Because when you talk about the exploitation on for example, some theft of the intellectual property, for example, or expose of the information, it's about the cyber criminal and not about the hacker, okay? And it's a misconcept, actually, and it's not correctly. And the idea of this project is to talk about this concept, okay? So I'm advocate here in Brazil, and we have many advocates around the world. I'm a coordinator of the staff team here in Brazil, in São Paulo, DEFCON groups. It's a small community to exchange knowledge about the security. I'm a instructor of the HackerSec. It's a Brazilian company responsible to provide some trainings about the pen testing, about the malware analysis in Portuguese language. And I'm a instructor, writer, and reviewer of those 3 magazines in Europe. And I have a course of malware attacks with the Q10 methodology in a Betask magazine. Okay, just a brief information about me. And let's talk about our main topic today, right? So first, I would like to put all those people on the same page to explain what is a threat. It's not my definition. It's the definition. It's about this ISO, okay? It's a potential incident, right? Or it's a potential thing that can happen in some arm or the system or cause harm to the system and organization, okay? But exactly what is a threat, Filipi? Maybe can be a software attack, or maybe a theft of intellectual property, as I mentioned. They explain the difference between the hacker and the cyber criminal, remember? And identity theft and sabotage and information distortion are example of the security threats, right? And it's very important to understand all those things. If you think about, for example, in startups company or the new organizations, or even old organizations, for example, in the beginning, you can have, for example, some code inside of this organization. Inside of this code, you can compile or not this code, and you can build this code, and you can generate some application or some container. In the end of the day, we have a software created by something. So when you have some potential thing, is a threat. Okay, just a simple definition about that. Okay, so before understand about the malware analysis, it's very important to understand the idea about how I can using this concept, or how I can put in practical about the malware analysis. So this is a simple cycle or flow about how you can using this in your investigations, for example. So first of all, you have the artifact. This is the first idea. And after that, you need to looking more this artifact is malicious or not. So it's an identification step. It's very important. So first you have a malware. It's a malicious software, or you have a maldoc, a malicious document. You don't know if it's malicious or not, right? So that's the point. It's very thing to understand that. Okay. So the second point is what kind of better or best strategy you can use in this, like what is the best methodology to apply. If you can use it, for example, statistical analysis or dynamic analysis, that's the point here. You have a different approach here. So, and I will explain more a simple concept again, what is the difference between, but here is the concept. And maybe you are thinking where I can use in the reverse engineer. Reverse engineer is a technique using in this specific methodology that you can use in. For example, you can use in reverse engineer in statistical analysis, you can use it in dynamic analysis. There's two different ways that you can use in the reverse engineer. It's very important just to clarify, okay? And when I present in these in different workshops, for example, or different trainings or talks, I recommend to the people what? To generate something. When you perform some investigation, it's very important you write these investigations or this study. Why? Because when you register that, you can improve your knowledge, because you can understand what is exactly the path used by the attacker in your investigation. And when you have this or wrote in this in some paper, email, or wherever, okay, you can prepare a report. You can, describe all those steps performed by the attacker. When you have this report, you can present this, for example, if you are an analyst, for example, you can present this to your manager, your tech lead, your coordinator. You can present this report when you perform some investigation, right? And what you can or when you have this report, what can you do with this specific report? You can improve your defenses mechanism because you understand or you understood what is exactly the path performed by the attacker. What kind of technique or evade technique used by the attacker, what kind of bypass the attacker use in your environment, what kind of adjustment or some adjustment in different configurations or settings you can improve your, for example, your firewall, your IPS, your IDS, your antivirus, your IDR. When you understand what is exactly the behavior of the binary, you can improve your defenses mechanism. And of course, if your company has the threat intelligence or cyber threat intelligence or CTI, you can build in a good way, right? So no matter if the company is big or small, you can create that. Of course, you will using a different tools to help you in this improvement, like for example, a MISP, malware information platform that you have many different IOCs. IOCs basically it's acronym. It means indicator of compromise, like some hashes or some domains, subdomains, informations related some attack it happened, right? And all those informations you can put in and correlate this information inside of this MISP, is an open source platform that you can generate all those information inside of that. So you can help you can using different tools to give you this intelligence in your environment. Remember, when you register all those steps performed by the attacker, you can improve your environment, your organization, right? And of course, you need to have this resilience because the threats are changing all the time. Because of that, it's very important you understand two simple things. First is how works the known threads. Remember that it's very important to understand how the known threads works. Why? Because when I understand how the known threads works, I can recognize, right, when about the different behavior. But when I know how the known threads works, I can identify, I can recognize when I find some known threads, because you can see different techniques or different behaviors, right? Okay, it's a simple cycle about that, or flow, let's say this way, okay? So what is exactly statistical analysis? Usually is the first step when you talk about the malware studies. Why is the first step? Because this is the process is described of how you can analyze the program code, or how is the structure of this code, or for example, what kind of function is imported by the DLL. For example, you have your operational system, many DLLs executing in your environment, but what kind of function you will imported by this specific DLL? So this is the idea behind of the statistical analysis. So the program itself doesn't run at this time. Of course, I put in here, depend of the program, because you can use in different tools to help you to see the result when you execute these tools. But it's very important to understand, when you talk about the statistical analysis, you doesn't run exactly the binary. You will looking more about what is the information you can extract of this specific binary, okay? Because of that, the person is more safe, okay? Because again, you don't need to execute the malware. When you talk about the dynamic analysis, on the other hand, for example, it's solely on behavior. And I mean, in the interaction, basically when you execute the malware, or when you execute the sample inside of the environment, or when you can use, of course, a different tool to help you. But in this case, the analysis is in runtime. You execute the malware and you see exactly the behavior. That's the difference when you talk about the dynamic analysis and statistical analysis, okay? Again, the reverse engineering a part of the technique using both of the methodologies that you can use. What the best, Filipi? Depending on the idea, you can use both, depending on how you can use. One way that you can use in the dynamic analysis is using tools to help you to automate out the process. Like you can using the concept called sandbox. So just to clarify what is exactly sandbox. Sandbox is basically it's a virtual machine isolated in some environment, but this is a point very important to clarify here. When you have some virtual machine, you execute the malware inside of that, it's not a sandbox. It's a virtual machine that you execute the malware inside that. But sandbox, to executing with the malware analysis approach, you need to have inside of this virtual machine some engines, right? Provided for some security stuffs like security vendors or an open source project. And these engines inside of the virtual machine will be responsible to identify what is exactly the behavior of this binary when is executing inside of the virtual machine. That's very important to clarify, okay? So it's a simple virtual machine that I will using in malware analysis to execute the malware. Is not a sandbox. It's a virtual machine with the malware, not just like that, okay? But when I can use in the sandbox, I need to have inside of the virtual machine some engines inside of that, right? And then, of course, you can extract some informations about these specific engines. I can extract the report. I can, take some report of that, and I can take some actions after that, right? So just to clarify that. Okay, so let me open here my virtual machine with you. Let's see if you can see here my virtual machine. Can you write in the chat? Can you see my screen here, guys? Let's see here if you can see. Can you see here? Yes, nice. So let me just a simple thing here. Once again. Okay, let me open here my Terminator and okay, can you see my screen here? Just a second, please. Okay, now I can, now is the best. Okay, perfect. Okay, now you can see better, right? So here I have here some files. Remember that? This is the first idea when I have some files to analyze. I have here many different samples, right? And I don't know if these samples, all those samples is malicious or not, but I need to investigate. Remember the first step when I mentioned about the identification steps? Okay, it's very important to understand these steps. So first of all, let me explain an important thing here. So first, I have, usually I using the file common to identify if the sample is malicious, but what kind of file it is in this case. I will set file common. In this case, I will talk about the Microsoft Word, right? So I have here another is a docx. It's the same. I think it's the same. Let's check another here. File, my friend Bill. It's a PDF document, and I have here the malware doc Python. Maybe it's a Python script. Is a text file. Let me read this specifically. Sample here. Yeah, it's a simple Python script. Okay, but how how the file works? That's the point here. When I'm using some tools, it's very important to understand how this specifically file, not specifically tools, or I can use another tools inside of this specific environment. I can use in more than one, but how the tools works when you looking to the binary. For example, it's very important to understand, or what is the rule behind of the file to identify this specifically file. For example, let me manipulate this specific file here. Let me put in some strings here. Let me save, and let's check what happened now. So now I have a Python script, okay? But if I try to execute this, let's see if they will execute here. I have some problem here about it's not correct string to start the file, right? And let me change another thing once again here in this specific file. Okay, let me cut here. Let me put in, for example, %PDF -1.7. Let me save once again. Yes. Let's see what happened now. In this case, I have a PDF document. I don't have more a Python script. Now I have a PDF file here inside of that. So if I try to read this specifically file, this is a Python script, but I put in here the %PDF. So do you know what that means in this case? Let me make a question to the attendees. What I am manipulating in this specific case? What do you think about that? And because I'm changing something in the beginning of the file, remember that. First of all, I put in three double quotes, and now I put here the %PDF, right? Remember in the beginning, when I put in just a simple, let me cut here once again, and I will save. And this case is just a simple text file, right? And you can see the difference between here and this specific file text, and here, once again, it's a PDF different, right? But something that happened here in the beginning, in the beginning of the file, but what is exactly, can you imagine what happened? The simple answer is here. We need to understand how the file works, and not only two, but the concept behind of that, right? So what is exactly the file? Is a simple tool that can help you to determine a file type. It's easy and too clear, okay? And here the explanations about some informations, but here you can see the key. All this file have a magic number stored in a particular place near the beginning of the file. So here is the answer specifically. So why, when I execute the file, appears first text file, the second it's a Python script, In the third appears PDF file. You can see 3 different files because I'm manipulating the specifically magic number stored in the beginning. So this is the important thing to understand. Another point is, for example, of course, the file command specifically using a specific databases inside of the, in this case, the system operations. And this is the information here by basically, or the information identifying this file is read from some specific place. This is the place, etc / magic, and the compiled magic file is here in this case. But as you can see here in the Linux platform, it's a compiled database, so we can't see the database. So here it's very important. Another point, very interesting, is in addition, you can, if you want, you can create your own specifically magic number. No magic number is your specific binary. If you want, for example, you can create, for example, doc Filipi, for example, if I want, you can create that. But how is this the file? How this exactly works, Filipi? So I download the source code of the file, the file to show you how this works exactly. Let me go through this specific directory. The file is C file magic and magic. I download from Debian. Okay, so here, as you can see, this is the databases basically from the specifically file database. Okay, so let me read, for example, JavaScript here, just to show you JavaScript here. This is here, you can find all those rules that you can find in the beginning of the file. It's very important. So if you have here this bin node, for example, in the beginning, this is the magic number, the rule that you can find inside of the binary. For example, let me create here some, for example, malware sample doctext. Okay, let me put in here malware. I will save here file sample. Okay, so let me copy, manipulate once again. Okay, I will pass here, save, and take a look what happened now. Is a Node.js script because I'm manipulating the magic number. Maybe you are thinking, so okay, Filipi, but how the file works when you talk about the PE, portable executable, or ELF, about the Linux, for example. So you can check here, for example, ELF. Let's see what happened when you click, in this case, in ELF. It's a different binary, okay? So, and to understand exactly ELF, we need to understand about the structure of the ELF. It's very important. So here is the explanation basically about how the magic number of the ELF works that you can see here. And this is the idea, or the people that are helping to create that. And if you see here, you have more than one rules to specifically when you talk about the ELF, as you can see here. So each one file has a specifically magic number. This is very important to understand here. As you can see here, for example, another Windows, for example, or you know, a VMware. Let's see another, for example, a PDF, my friend PDF. So let's see here the strings behind our PDF. Take a look at the strings %PDF. Remember when I wrote about PDF? So here you can see specifically, you know, %PDF dash and the version specifically here in the continue of the is the version in this case. Okay. So as you can see here, here is the idea behind of the file. So it's very important to understand about those bases. So you can use, and of course, different tools to help you, but it's very important to understand how these tools exactly works. For example, let me go to this Linux folder. I have here different malwares here, right? And maybe you are thinking, Filipe, I don't have these malwares. No problem. You can use it. I will show you here. This is my GitHub. okay, Filipi 86, basically. You can see here, you can go in my repository here, and you can click here, basically the zoo, okay? Here it's not a my repository, of course, I forked this specifically. You can go to the zoo repository, you can click here in malwares, and you can click here in binaries. And after that, you have here more than one malwares. Remember, this is a real malware, okay? And by the way, I like to work just only a real malware. I don't know why, but I like, okay? And you can see here different malwares here. You can see here malwares for Android, a system operational system for mobile, for example. You can see here CryptoLocker, it's a kind of ransomware. From APT's group. APT's, it's advanced persistent threat groups. Okay, equation group is from some APT groups. And let's check some in JavaScript and for a Linux environment. And I download basically this encoder and this chapters, for example. I download in my virtual machine from macOS, from macOS, for example. Another kind of ransomware, Cerber, CryptoWall, Gigasaw, and Tesla Crypts, and the famous WannaCry. And let's see another here, Trojans. It's a different Trojan and Dropper. It's a different behavior, right? So Dropper, usually you have some code inside of your environment, inside of the malware. Here, Trojan for different system operations. From Stuxnet, for example, another very known attack. Some VBS or okay, you have here more than one. And if you want, you have here another very nice repository. It's a bazaar.abuse.ch. It's a malware bazaar. You can click here in malware bazaar database. Basically, this is a repository that the community can upload different malwares inside of that. And you can see here, this is all those real malware. That you can see here, you can find the type of the malware, in this case, using DLL, executable file, document file, MSCE, ELF, and the PDF as well. You can use in basically this a simple syntax here. Let me show you here. You can click here in syntax. You can see the different syntax. You can use an MD5, signatures, based on tag, for example, some YARA rules you can use, and some impl hash or in other different tools, like you can use in, for example, tag doc PDF, for example. Click enter here, and let's see and take a look at. If you go through here, you can click here if you want. I have here the binary that I'm using here in this workshop, right? So it's basically here if you want to download here. Okay, so basically to upload files here, you can basically need to register that. You need to use in some Twitter account, and just to using to register, and you have available to some APIs to using some tests. And I can show you after this presentation, or during this presentation, so I can show you some tests that I'm using this, right? And okay, and let's continue here. Let me return here to this specifically binary. Remember, as I mentioned about the some important information that we need to understand about this specifically when you execute something, right? And for example, remember I explained about the file. So let me explain about the strings. It's very important to understand. For example, let me using here an information for hexadecimal Erebus. It's first, let me explain what is exactly Erebus. So file Erebus, it's a kind of malware in ELF, okay, is a ransomware. If you're using, for example, hexadecimal Erebus, before I use it, dash any 120 bytes from Erebus, okay? So let's see here. So here is basically this information in hexadecimal information in this side, okay? Here is the open code or open, it's a offset of the file. And here is the string converted by this specifically hexadecimal information, okay? So as you can see here, this is the beginning of the string, ELF. And let me show you another here, not another, let me explain here, 250 Erebus. Let's see more strings here. So just the elf here. Okay, so let me just explain about the elf -a, because I would like to see all those strings in this specific Erebus. Remember that. So I put pipe last here to start in the beginning of the file. And take a look what happened now. This is the beginning of the strings of this specifically binary. Take a look at that. So let me do a question for you. If you see here, didn't appears these strings. Why didn't appears elf? So if you go to once again, for example, let me put in here the 100. I don't know if it appears in this. No, not appears yet. More bytes here. Here, let's see here. Yes, take a look at that. Appears at this moment, right? When I execute the strings, appears is exactly in this moment. Remember that? Let me put it once again. Take a look at that. The information of the library using in this case, right? So this is the library using to execute the necessity to using this specific library to execute this elf file. But my question is, why didn't appears these strings? You know, or you don't know? It's a good question. It's very important to understand that why didn't appears. This is the very important, the basis, because you can use in your many different tools to help in the results, but why didn't appears? Why didn't appear some information to identify or to find some information? The explanation is very simple. It's here. Because first, what is strings? It's a printable of the sequence of the characters, right? So the printable sequence characters. Iran putting encoding. In this case, Iran is not encoded. Here is the information. Strings prints the printable characters sequences that are what? At least 4 characters long. Because of this simple explanation, it is because of that didn't appears elf. So let's check, for example, another very interesting thing here. And for example, if you're using, let me put in here, okay, return here. Let me return and go to Windows, for example. Yeah, Windows. Let's check here. I have here some samples, so some hours actually. Sample here, it's okay, I think it's this who is. Yeah, take a look at that. It's not a feature, it's actually, it's a part of the information of when the author of the strings created this specifically tool, or the idea behind of the string is just to printable, it's to print at least 4 characters, so that you have the 3 characters didn't appear when using strings, right? So that's the explanation about that. It's exclusive because of that. Okay, so let's see, for example, XD here once again, -32, because I would just to print 32 bytes, and I'm using here who is. Take a look at that. It's a MZ. This is MZ signatures. And basically, when you're using to identify some, for example, a portable executable from Windows, you need to have more than the 2 different informations of this specifically binary. It's a MZ signatures and PE signatures, right? Let's put in here, in this case, it's a 300. I think it's a real appears. Yeah, it's a PE. It's here. Yes, yeah, so this is the translation of, not translation, the conversion of the hexadecimal to the strings here, and 50 and 45, right? So this is the hexadecimal information, and it's the string, and here the MZ. If you see, if I execute here strings -a and who is once again, and pipe less, in this case, it's starting here, and this program cannot be run in DOS mode. And if you see here, here is the session, right? So 4th fashion in this specific binary, as you can see here. And if you return here, take a look at this. Didn't appear because it's just two printable characters. And PE didn't appear because it's two characters. In this case, appears this phrase because it's more than 4 characters, right? So it's very important to understand all those steps inside of that, right? And if you this is very important to understand when you perform some malware analysis, right? Because remember, this is just the first steps about that. So let me explain another thing. For example, when you talk about the first steps and what kind of information you can collect of this about that. For example, I have this file here, file whois, specifically a PE. It's a portable executable for 32 bytes. It's an executable. This is the architecture, right? So Intel in this case for Microsoft. Okay. So the second command I can use is the strings -a. If you don't know, or if you can use in -h to see about what kind of command you can use. Basically, it's a command you can use. Okay, in this case, I will use in -a because I will scan the entire file. Okay, just to explain the command, right? And whois. Okay, sorry for that. Let me put here the beginning pipe less because I would like to see since the beginning. Okay, this is the program cannot be run. Okay, so let's try to see more information just to understand about this string. Is remember, this is a not reverse engineer. Okay, it's not reverse engineer. It's just a simple first step to executing in the malware analysis studies and to some investigations. Okay, so just to collect some information about this specifically, because I don't know if this sample is malicious or not. I just have this simple whois, the name of the file. It's a binary, it's a portable executable, just simple information. And here, as you can see, I can see by the way, for session, it's a part of inside of the some. In this case, when you talk about the portable executable, you have the headers, more than one, and you have the sessions. Inside of this session, you have the text session, or a data, it's a read, read data and doc data, and or S or C. This is the session usually used by to appear the icon in the binary. Okay, so let's see here what kind of information you can find here inside of these strings or some interesting informations. Let's see here. I'm executing here in the manually way. Okay. So let's see here, and okay, so here take a look at some possible interesting information. Close handle, get as it code process, terminate process. So here we can find some information about something, but in this moment I didn't know what is exactly. So load library, it's the function to executing to load some information inside the system operations, to go to some process, but I still didn't know. But what is exactly this, Filipi? This is basically is a function. It's a function imported for something. But why is important, or what not important? Imported for something. So where is the place, or what is, or who is imported? In this case, this is a function imported by DLL in this specific case because it's from PE executable, the portable executable. Okay, so this is a functions or many functions imported by the some DLL, but I didn't know in this moment for now what is exactly the DLL. So just to see, delete critical sessions, maybe why some important functions, delete a critical sessions, write file. Let's see here, copy file, open mutex. I'll take a look at the sleep function. So let's investigate more about that. So is sleep function, Microsoft. This is very important when the steps. I'll take a look at that. Here you can see the some information, the sleep function. So let's see here if you can find some interesting information about that. So this is take a look at that. The sleepy functions, right? So suspends the execution of the current thread until the timeout interval lapse, right? And I know this is the specific function. I know what that means in this case, but just to understand what is the idea behind of the investigations. Maybe you are thinking, but Filipi, I need to, if I don't know, I need to open all these functions to understand. Yes, this is our job. We need to understand all those functions and what you need, what we have inside of that. Because when some attacker create some malware, the attacker knows how the functions works, how the library works. And take a look at another very interesting here. Create a directory. So they will using these functions to create something in your environment. Remember that. And because of that, this is a specifically functions or technique basically used by the attacker to bypass some sandbox. Why? Because when you have this specifically function, you can suspend the execution, because the attacker, when the attacker creates some malware, they can put these functions to understand if the malware is in a specifically sandbox. So if the malware is inside of the sandbox, the malware didn't execute or doesn't execute any malicious function inside of the sandbox. Because of that, the attacker using this specifically function, the sleep function, right? So this is one of the idea behind of these specific techniques. So let's see another information here. Take a look at Kernel 32 DLL. And we need, when you talk about the threat researchers, we need to understand what is exactly kernel 32, what is a user 32.dll, and take a look at other things, other informations about that, right? So we have more than one functions imported from some DLL, and let's see others information. So maybe here, close something, write something, read and open. So we need to understand about that. So let's see about the comments about the error. You can usually run the malware in a virtual machine instant of the sandbox and monitor it's a proxy monitor or a similar filtering program. Yes, perfect. It's a good way you can use it. But remember, to executing that, first, you need to isolate, of course, this virtual machine of the network. First, it's very important, and you can open the proc monitoring to understand about what is exactly functions important in DLL. But sometimes it depends of what kind of function they will be using, what is the time using this specifically, and of course, you need, and not you, Aaron, in this case, but the people that are you executing this virtual machine need to understand how the proc monitoring works to identify all those steps, right? It's very important to understand that. Okay, so let's continue to see here. Take a look at here. Whoops, take a look at that. Very interesting information. CDoc WN or NY here. Maybe it's here, it's some acronym, and here it's information about the what? WannaCry. And take a look at that. Delete file, move file, read, write file, and some RCA. So take a look at, I don't know what is exactly this specifically malware, but in this case, I see here some string telling WannaCry. So maybe this is a ransomware, right? So this is the idea, right? And let's see another comments. Great talk so far. Thank you. And this is a place to both Windows and Linux environment, right? The idea I am using here and just a simple Linux environment, right? So if you have a time, I will start my Windows machine and I can show you some analysis in the Windows machine to see using another tools. But the idea behind of the analysis, you can use in both of the system operations, right? Because again, this is just a way that you can use it to analyze. But the idea behind of the malware analysis and the investigations about the threats is always the same. Okay, just to clarify. Take a look at another crypto informations. Okay, so maybe we can agree with me that this is a WannaCry, this is a ransomware, right? And take a look at the execution of the CMD calling something. Take a look here, the parameter, okay? And executing this specifically task doc execute. Let me just to show you here, simple. WannaCry. Let's check here. Take a look at the functions. It's a simple one. I put in the on the internet. Take a look at that. It's totally linked. And of course, in 2017, I worked and Trend Micro, and I know this is the binary responsible to encrypt the environment. I know, but I am supposing that you don't know. Okay. Então, so if you see here, take a look at that. This is the specific binary responsible to executing the encryption in the environment, right? So this is the specifically binary, okay, inside of this specifically malware in this case, because now I know that is a malware. I can use in another tools to help, and let me using the grep here, okay. Let me close something here, okay, grep-e, because I will search for expression regular inside of that. Let me put in here the DLLs and click enter. Take a look at that. Here is all those libraries or DLLs using in this specifically malware. And take a look how is very important to understand all those DLLs, because I have more than one. Take a look at this. This is a specifically DLL using to call some API or using the Windows API. Here you can see some probably executing some shell using this shell 32. But remember that when I don't know what is the functions or what is DLL or what is the functions imported by DLL or what is this specific DLL, I need to investigate this DLL, because remember, in this case, I'm talking from the Windows platform. So I need to investigate, I need to search more information about that. For example, let me put in here kernel, you know, doc32, kernel32.dll Microsoft. So here, as you can see, the information, it's in Portuguese, we change it for English here. And here you can, you know, you can search about what is exactly DLL, what is the functions, or you can put in here the documents, for example. Another way, you can put in here the documentation, so it's better. Take a look at the functions here, or here from Microsoft, what is exactly the threads imported or the functions imported, right? So it's very important to investigate more about that, okay? So let's see another information inside of this specifically malware message. Wow. Take a look at what I found here. Message / Bulgarian, Chinese, Czech, Danish, Dutch, English, Finnish, French, oh, Portuguese, yeah, Spanish. So what do you think, guys and ladies? What do you think is this specific message? Write in the chat. What do you think about that? Yeah, this is a demonstration of the malware, okay? But what is this message? Do you know? Do you imagine what is this specifically? Nice. This is the correct answer, right? Perfect. This is the ransom note. Perfect. Exactly. So this is written. Sorry if I pronounce it wrong, but this is the correct answer. Okay. Basically, the ransomware has a ransom note. This is the information printed to the victim machine. Okay. And if you see here, basically, probably the malware, or not probably, probably the binary has some DLL. Take a look at that. This DLL has some functions imported from this specific DLL, and this DLL is responsible to read what? what is exactly the system operations and the victim machine. When the DLL is executing this and to identify these system operations, they will using another DLL to print this information to the victim machine, right? So that's the point here. So the malware has a library responsible to identify what is exactly the system operation. And after that, when the attacker is finished, the attacker can print this ransom note and according the system operation of the victim machine, and they can using all those ransom notes, you see? So it's very, very, very interesting. Remember, if I receive this binary and I don't know if this malware is malicious or not, and if you see here, it's totally malicious because it's a WannaCry, it's a, you know, we found here others information. So let me check, for example, just to confirm that. And chat is 2567, and I put here who is, and I will copy that. Copy that. I will using the simple virus total. This is the antivirus scanning. Okay. To find something here, let me put in search. I will paste here this SHA and take a look at that. Let's see, is a malware, is a WannaCry, as you can see here for some engines. Okay, it's a WannaCry. Let's see the questions. Can the attacker scramble or obfuscate the executable file, or they must using clear text in order to using DLL / SEO libraries or like scramble? Good question, Orion, good question. So I will show you, usually the user can use, for example, some packer to unpack the session. And I will try to show you in the Windows and the Linux, and after that in the Windows machine, okay, to show this difference. But the attacker, usually they like to using some a packer. Let me explain. But just to finish, this specifically binary is a malicious, okay? So let me turn here. Let's check here Windows. Here I have another very nice to show you. Win32 Ransom. Okay, so I have here more than one binary. Okay, Win32. I know this is it's a totally malicious. Okay, I have here more than one. Take a look at that. Let me check here, for example, file doc executable. I think is that 119 doc executable. This file, okay. And let me click enter here. Take a look at that. UPX compressed. Okay, so in this case, the attacker using here the packer to uncompress some session. Let me put here the string -a 119 doc executable. Take a look at that. Oh, sorry for that. 5 less. And nice. Remember, guys and ladies, when I execute this in the beginning, appears here the doc text or data, it's a read only, and doc data and doc or S or C. Remember in the first binary. So if you compare with this specifically, binary is different because you have here the UPX0 and UPX1 is different, right? Those differences happen because in this case, the attacker using packer twice to unpack 2 sessions inside of that. Sometimes you have some antivirals or IDR. It's when some binary has a packer, the engine behind of this security sensor putting this sample has a suspicious, because usually it's part of the technique used by the attacker. Okay, and in this case, this is one of this technique. Let's check here another here. Yes, they can encode or encrypt packet the data. Exactly the answer of the error. Or can attacker obfuscate why those packer metadata? Yes, they actually, the attacker can using some, for example, anti-disassembly techniques and more than one. For example, let me using other tool to help you. Let me, for example, I don't know if you want, but you have a path project. It's let me write here, path project. No. Reversing engineer. This happened this way. It's here, but not here. This is the project, okay, but here is the project, okay. From Fernando Mercedes, it's a Brazilian guy, by the way, but this is the source of the project. You can use it, of course. All those projects are inside of the Windows, the Linux platform, okay, but you can use in here more than one. Basically, here's the source. You can find here more than one tools to help you to executing some commands you can use in the Linux, Windows, and Mac OS. Here's documentations, and the week that you can using is maintaining of the, this is the contributors, code contributions, and the maintaining, I don't know it's a maintainer now, but it's created by the firm Mercedes, but you have a package of the tools. And by the way, you can see here one of these tools is a scan, for example. You can use one of these. Let's see if this appears here. Scan. Yes. So here you can see you can find here the entropy of this specifically malware, and you can see here the some anti-disassembly function used by the attacker. So the attacker can use in more than one specifically techniques to difficult actually the analysis from the researcher. Okay, and that's the idea behind all that. You know, in the end of the day, we have the attacker and you have the researcher, the analyst. Because of that, it's very important to understand how the basis works. Because when you understand how the binary works, how it's created, all those sessions, how is the library or how the library works, what is the functions imported by the DLL, all those information is very, very important to understand. Okay, so let's see another question here. So if you encrypt your code to bypass endpoint security measures, would be better to use decryptor or logic bomb to activate? Coop, it depends. Actually, it depends of the idea behind of your tests, right? Because remember, when you use, for example, some packer, remember, of course, when you create some malware, remember that malware, okay, for a test, okay? When you create something like this, it's very important to understand how the antivirus, how the IDR and the point of detection response works, how the engine response for this specific binary works. Because when you understand exactly that, when you understand how is the behavior of the engine, you can create something to bypass that, right? And that's the point here. How do you turn off the AV? Depends on the idea of the end of the day, okay? But again, you can create a virtual machine. You don't need to install the antivirus, okay? But if you'd like to bypass the antivirus, it's very important you put in the controlled environment, okay? So in this case, answer to the COOP, it's very important to understand how the things works, and you can create many different things to active and to of course, remember, sometimes you can using, basically this is the idea behind of some using by the attackers. Sometimes the attacker using the real functions from Windows or from Linux to execute something, right? For example, the Windows has some encryption functions. So you can use in this specifically function because it's a known crypton, right? It's a known cryptography. It's a known by Windows. You can use in some Windows functional API to call something. You will use in some function from this specifically library from Microsoft. So the attacker using actually the true functions to executing malicious stuff. And that's the idea behind for some attacks. So that's the point. Because remember in the beginning of this conversation, I talked about the malware hunting. Remember that? Right. So that's my idea when I explain about the malware hunting. Because malware analysis is more defensive approach. Okay. Threat hunting is another defensive approach. But when you talk about the threat hunting, it's more looking to about the logs, about the CMs, about the tools that you can show you some logs. But my approach when I talk about the malware hunting is how you can looking more deeply about the binary. What is the behavior of the binary? It's very important to understand that, okay? So that's the idea behind of the hunting. How you can hunting the binary more deeply, okay? So that's the point here. Would state-of-the-art of sandbox technology detect this type of the tricks? Yeah, actually, it's a good question. Usually, when you talk about the sandbox, we have more than one. Let me go through here. For example, returning here in my GitHub. Let me return here in the beginning, Filipi 86 and repository and click on awesome. I put in all those projects here in my GitHub just to be more easier for us. Okay, and let's put it AppSec, red team, and let's check here malware analysis here. Let me click here and go to this awesome malware analysis. This project is from this specific guy here. And you can go through the, let's check here, sandbox. Let me sandbox here. Yeah, it's online scanner and sandbox. So here you can using this specifically sandbox. Oops. Online scanner and sandbox. Take a look at that. So here you can find some cloud sandbox that you can see some informations, and of course the question is about the technologies to detect the malwares, and many of this security sensor or security sandbox has many engines inside of the sandbox. Remember in the beginning that I explained the difference of the virtual machine to using in some tests and the sandbox. To using sandbox, we need to have the engines inside of that. And this engine is responsible to detect these specific tricks and other things about this specific malware. You have here very known Google Sandbox, very known, it's an open source. I use it. This is a very nice, very nice drag wolf. It's a very nice sandbox. And of course, we have another Joey Sandbox. It's very nice. Hybrid analysis, another very nice sandbox. And you can test, Filipi, what is the best sandbox? It depends of your environment. This is PDF Examiner. It's very nice to analyze the PDF. And for example, VirusTotal, it's a kind of sandbox. It's not a sandbox, it's an online scanner, because if you see here, you have many engines. All those engines is inside of this specifically. For example, how exactly VirusTotal works. So all those companies offering one engine or more than one engine from VirusTotal, and this engine is responsible to detect this specifically binary when you upload something here. For example, you can upload chose file here, you can upload the file here, and after that, all those engines will analyze this file. So it's a kind of sandbox. Okay, so that's the point here. So let's return here. So we have many techniques behind of that. And let me explain another thing about I talk about a lot about the PE, portable executable, is some tools that you can help you, right? So let me return here just to explain another thing about, for example, let me go to Windows once again, about the package, about the PEV project. Once is we have existed, it's very known to read PE. It's a very nice tool from PEV project, and I can use it here for example, to see more information about that. So here you can see the structure specifically of the binary. Take a look at the DOS header that you can see. This is the magic number, the MZ. Remember when I explained about the magic number, okay? And you can see here the information, the string, the hexadecimal information, and here the string MZ. And take a look at others information, the file header or conf header has a known, right? And others informations, okay, optional header. And here it's very important because here, if you have some notebook, for example, you can take notes that, remember, as I mentioned about you need to register all those things in your investigations, right? And here is imported functions from the libraries, okay? And take a look at that. This is the kernel 32 doc.dll, and this is specifically binary. This is, or these are functions imported from this specific get file attributes, get file size, create file, initialize critical session, and all those functions are imported from this specifically kernel 32. Okay, here is the sleep functions, open mutex, and let's see here another, the next here. Take a look at that user 32 DLL and this is specifically function. Just only one. Let's check here. For example, let me pass here and function Microsoft, just to understand. Okay, let's see here the documentations, the informations about that. This is it's a functions. It's a function, it's a printable. Let's check here. Okay, let's check. Let's see here, write the format of data. In this case, it's just to print something. More secure versions. Okay, let's see if we have another parameter or functions. Let's check here. It's just to print something. Write format data to a string. Okay, it's a print. It's responsible to print something. But in this case, you have here specifically, this is the functions imported, but they will print something related to the specific parameter. So I'm supposing now they can using this specifically function to print this information to using, for example, through the ransom nodes, for example. I can using in this way. Let's check another. Here in the using the API window, so create some services, starting as services. So here it creates some keys or register key actually. So they will using this specifically DLL to changing something inside of the register key, as you can see here. So creating some value, setting different value, or requesting this specific query. You can see here these specifically functions are imported from this specifically DLL, and they will create and manipulate something in the registry of the system operation. So you can see here many things divided using the functions imported from this DLL or this specific DLL. So as you can see here, many others informations, and here is the sessions. Take a look at that. And here is, for example, the session, once again, doc text, okay? The sizing, the information, the virtual address, the many others information that we don't have to explain during this webinar, or data, doc data, and doc or S or C. Let's see another, let me return here and let's compare with another, remember another binary. If you remember, read PM 119.executable. Remember that we have inside of that a packer. Remember in this binary specifically, just to compare, let me go through specifically kernel 32, loader library, get process to very, it's a true process, but usually you always find this two specifically functions import of that, reg close key. Let's go through the session. Take a look at that. Session 1, UPX0, session 2, UPX1, and 1 or C or S or C. In this case, so Filipi, how I can analyze if I have two different sessions here? First of all, we need to unpack it this two specific session. And after that, you can analyze, you can go through to analyze this specifically session. Okay, so just to simple clarify that. So I put in two different malwares in this case. So let me go through a different way. Let me explain more about another very interesting thing. Let me return to file man here. And I would like to explain another very interesting thing here. Let me go through this specific information here. The canonical example of this and a binary, because in this case, the file are explaining about how the file is or how the binary works, talking about the file systems and our base to examine something inside of that. And they will explain here about the specific, some magic tests that you will use in this specific analysis, because they will check some specifically and particular information inside of or specific formats. They explain about how the file system works, how the possible binary works, and take a look at about some example. And in this simple example, we can find very interesting information. So here, whose format is defined in the elf.h. So here, the tools give us an interesting information. Let me copy this specific file here, and let me locate here. There's a specific binary. Let me go through here. It's user included. Let me copy here. Let me go to this specifically. Let me read actually this specifically file. Oh, first of all, let me check here. What is this specific file? Let me check here. It's a ASCII text, but it's a C, the source of this specific file, right? Probably the magic number is from a C programming language, okay? So let me read now this specific file. This file defines standard ELF types, structures, and macros, okay? So nice, very nice. So here, as you can see here, we can find the structure specifically about the ELF. We talked about the Windows. So now we're gonna talk about the ELF, specifically ELF from Linux. And if you see here, you can see there's some structure or types of the 60-byte quantity and a half. In this case, in 32 bytes, we have a different word as word. In 64 bytes, we have a X word, SX word, and so on as a type of a specifically size of the binary, okay? And nice, let me go through this standard information. So first, we have the ELF file header, okay? This appears at the start of every ELF file. So when we analyze the ELF file, always appears this information in the beginning, the help. In the beginning, we have these specifically 16 bytes, right? And this specifically byte is a specific array called e-identity, as you can see here, right? So in the beginning of the all ELF binary, we have the 16 first bytes, we have this array called e-identity. What kind of informations I have inside of this specifically array, Filipi? We have a magic number and others information. Oh, very nice. Other information. Very clear. Okay, so we need to investigate more about that. Okay, but very important, we have a magic number. Nice. But what is exactly this other informations? Let me go through this specifically file. Okay, nice. Here, fields in this identity array, as I mentioned, we have all those information. Remember, 16 bytes. And in the first positions, we have here the byte 0, as you can see here. The position 2, we have this second byte. Position 3, we have this another, and in position 4, we have this specifically ladder. So if you see these 4 informations, we have a what? We have the word elf, right? So let me split here in a vertically. Let me go through here. Let me go through the Linux. And let me put here XD and 32 Erebus. Okay, let me show you this information. Take a look at that. First positions, it's 0. The second positions, it's 45. The letter E. Position 3, it's the letter L. And position 4, it's letter F. Let me go through another here, Linux 32. Yeah, 32, 5 less. No, not necessary, 5 less. It's the same, you see. Let me put in here the 64. It's always, guys, always the same as I mentioned. Not I mentioned, has the documentation mentioned, okay? So the first position is always the same, but now take a look at that. The position number 5, take a look at that. Is here we can see 2, and here we can see 1, and here 2 once again. And take it, that's the sequence, it's 0, 0, 1, 0, 1. In the end of this sequence, 1, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, position 8, 0, 0, and this case is different, it's 9. So we can see here we have some difference between, and this specifically, this and this. So we can compare those 3 files, okay? Just to be clear about how important it is to understand the structure of the binary. Remember, this is the important understanding or the acknowledgement about how the structure of the file works. So let's see another position, okay? In this case, the position number what? Let's check here. 1, 2, 3, 4, number 5, position 5. Number 5 is the file class type specifically. If you have 0, 1, is because the file is object 32. If it's 2, is because it's a 64, sorry. So let's return our file here. Oh my goodness. Sorry. Okay, let me change here. Just a second. Let me open another because, you know, okay. I will be terminal here. Much better. Linux or Linux. Okay. Let me go through XD. XD Erebus. AD32 Erebus. Okay, XD AD32 Linux 32. Okay, and XD any 32 bytes, Linux 64. Okay, so now we can compare. Nice. Okay, much better, right? So in the 5 position, so if in 0, 1, it's a 32 bytes, it's a 64, it's a 64 bytes. So let's see here, number 5 here. In this case, this specifically binary is a what? Is a 64 bytes, because as you can see here, it's 0, 2. In this case, it's 1, it's a 32 bytes. In this case, 0, 2. So let me check here once again. Erebus is at 64 bytes. Remember that it's here the informations. Remember, I am talking about the first array key ident. Remember that. The next position, so it's about the little Indian and big Indian. It's 1, it's a little Indian, and 2 is a big Indian. Big Indian. In this case, it's 1. It's all those files are, in this case, a little Indian. It's very common. Okay. So let's see the check another number 7, I think 3, 6, 7, and this 0, 1 is 0, 1. All those files in this case is 0, 1 is from Unix in this case specifically. Okay, so let's check here the last one, number 8. In this case here is about what? Okay, it's about the structure in this case. So let's see if you 0, 1, it's relocated file. 0, 2 is executable file, or it's no, it's sorry, no, not that. It's here. Number 8, it's about what? Let's check here. Okay, it's about the ABE version. Okay, it's not about the structure. I made a confusion here. This is the sequence. Let's return here just to explain. Position 1, 2, 3, 4 in this case, and this is the 5 position. Okay, and this is the 6. Let's return here. 5 position and 6, and this is the 7. And sorry for that, this is the 8 position. Okay, this is the position, the version of the file. Okay, number 8. Let me return here. Position 8 is that. Sorry, it's 7. It's here information. My bad. Okay, and 9 in this case, as you can see here, it's a free BSD, right? And in this case, when you see here, and 0 in this case is a Unix platform, as you can see here, or they can use in some alliance. But in this case, it's because it's Unix platform. So as you can see here, it's too clear about the specifically where is the position of the binary. Okay, so I executing here the specifically exadumping tools to print us the informations. Okay, and here I will set the specifically volume of the binaries that I would like to print, and here is the file. And as you can see here is the position about this specifically binary. And if you compare with the documentations, all those informations you can find exactly here. Okay, and this is a very important. The next, for example, the next session after the 16 bytes, you have another array, right? And the next is EI underscore type, right? So, and the position 17, in this case, this is the position 17, okay? And if you see here, all of those is about the 02 executable file, right? And as you can see here, all those is executable file. So let me check here, for example, just to show you, file xdump Win32 USF bin thing. Yeah, this is, you know, it's a command. This is the command basically, right? And if you see here, take a look what happened now here. This is it's a ELF, okay? I'm using here in Unix platform. Let's compare here. So if you see here, so take a look that this is the, if you're using here, because remember, I'm not executing now the malware analysis, but I will need to understand how the system operations works, right? Let's check here if I can. Oh yeah, of course. Just to compare. Because ls is a command, it's a binary. Remember that it's a binary. I'm executing here ls, it's a binary, okay? And if you see here, it's a elf 64. As you can see here, it's a 64. Remember that 64. And if you see here, it's 03 is not 02 is not a executable in this case. Of course, it's executable as in this case, but in this case, it's a shared, specific shared object file, because they're using some ACLs information inside of the system operation. They're using some dynamic, some different approach inside of the system operation. But just to show you how some information is important, you can see here, and how important we need to understand all those bases inside of the system operation, right? And if you see here, we can using, for example, read elf to read, to see these informations about the malware, right? And if you see here, I need to set dash read elf dash h, I think, yeah, dash h. And here, take a look this, the magic number and all those information. Remember the 16 bytes. Remember when I execute, when I read here in the documentation, remember that? Yeah. And here is the class elf64. It's a really little engine. Remember that 01, as you can see here, when you compare to the documentation, the standard informations, as we can see here, where is here, identity, it's a little engine 01. You see? And the system operation, take a look, that is a Unix platform, as we see here. And this is specifically information here, Unix 01. I mean, there is all those informations you can see inside of that, as you can see here, you know. And here you can see all those headers inside of these informations. You can see here the specifically sessions, because usually, not usually, but when you talk about the ELF, you have more than one session. It's many different sessions and so on and so on. Okay, so, okay, let me finish this part. I think we have more 30 minutes, I think. How many times I have, Amy? Can you write me just to it's almost finished? Yeah.
Officially an hour and a half, but if you want to continue, that's fine.
Yeah. Okay, I will need to continue. Let me return it to the presentation. And just to explain about the PDF, right? And just explain simple information about the PDF structure, okay? And because it's very important. And this is generally we have 4 parts in PDF, right? So we have a header, we have a body, and you have a cross-reference table, and you have a trailer inside of that, right? So it's divided in 4 parts to analyze. And this is specifically 4 parts. We have a version in the beginning, we have a body, and inside of this body have many different objects, and all those objects are accessed by the cross-reference table or X table. So what is Filipi cross-reference table? It's a locations of object within the file for random access. Remember that. So we have a main object, not main object, sorry, we have a specifically body. Inside of this body, we have many objects. All those objects are accessed from this cross-reference table, and a trailer access in a way a random access, as you can see here, the explanation. Okay, nice. So let me show you this demo video, because again, we don't have more time to explain all those steps and explain more details about that, but just to show you this specifically demo and some analysis that I made in some PDF file, okay? And if you have any questions, you can send me after this presentation, you can write me something. So basically, if you have here the file, the PDF file, basically this file you can find on the Malware Bazaar, remember that? And I show you can go to the Malware Bazaar, you can set in the syntax tag, you can set tag, and you can put it in the PDF. In the end of the tags, in the end of the many files, you can find my specifically at Filipi Peers. Okay, so I executing here the file, as you can see here. The next, I using PDF ID from DJ Steven. DJ Steven is a very known researcher. They have a blog, a web, very known, very nice DJ Steven's blog. They have many information about the PDF and other tools. And as you can see here, we can find 15 objects. Remember that, 15, okay? And we can find 2 different streaming. Usually the streaming is a part of that the attacker can put in some content inside of the streaming. So if you have many string inside of the PDF, maybe it's a suspicious, not because they have a malicious, suspicious or malicious things inside of the streaming, because usually this is a part of the inside of the PDF used by the attacker. Okay, so if you have, I don't know, 15 streaming, you need to investigate, you need to look more deeply about that, you need to investigate and see more deeply about that. Okay, and if you see here, you have a different slashes here, for example, slash page, slash encrypt, slash something about the JavaScript, some, for example, open actions related to the open action or AA. So when you have this specific tag, it means that the user don't need to interact or click or executing more than one times the binary. They simple download the file inside of their environment or itself. The environment, the user download the PDF inside of the victim machine, and after that they just need to open the file. Just for example, if you receive some CV in your email, if you download this CV in your environment, if you click into open, it's enough, because after that they will execute something automatically. Because of that, you can see here when you have this open action functions. Okay, so the user just need to click to open the file. Okay, and after that they will execute some functions automatically. Okay, just to explain these information. So take a look at that. We have a 5 JavaScript inside of this specific PDF, and we have an open action, and you have 2 streamings. So it's totally suspicious, right? Because we have many suspicious information. So I'm using here the second tool, PDF parser, to search some information inside of this specific PDF. And I can using, for example, I can set -F to search, for example, or not dash, no F, S, it means search, because first I will search for a JavaScript. We can find in object 1, an object 7, and object 12. Take a look at this, 3 JavaScript. So I will set another different here, JS. Remember about the slash. So here you can see object 1 and object 12. It's 2. In this case, we have a 5. Remember that? This is the reference here, 5. So simple like this. So if you have JavaScript inside of the PDF, maybe it's a 80% suspicious. It's my opinion, okay? But and the second parameter that I'm using here in this investigation is -A, is -W. But what that means, W flip in this case? In this case, it means run, because I would like to see the run output for data and filters. I'd like to see all those run data inside of this specifically PDF. CV, as you can see. So if you work with the HR team, you receive the CV. Take a look at that, very important information to clarify. Remember when I mentioned about the random access, so all those part of these specific objects are linked, each one in another, as you can see here. So we have an object 1. Inside of this object 1, we have a 6 reference. Object 2, 3, 4, 5, 6 at 7. So as you can see here, we have 6 new reference with this specific object. Object 1 referring more 6 objects, okay? And another interesting information here, it's about the specifically open actions. Remember what is open actions? So the user does just need to open the file, and after that, they will execute something automatically. So if you see here, these open actions is totally linked to some JavaScript, as you can see here. So basically, the user received the PDF. When the user open the PDF, they will run a JavaScript, okay? Object 2 and 3, nothing. Object 4, we have a new reference here, object 8 and 9. But remember how many objects we have inside of this specific PDF? 15, okay? Let's continue to see. We have object 5, 6, object 10, we have a new reference, object 10, and in this object 10, we have a JavaScript reference, and object 8, it's more about the pages and image, okay? And object 9, we have a more 3 new reference, as you can see here. Object 10, we have, remember the JavaScript, we have here the JavaScript referring object 12, and here we have the first streaming. But in this case, the left, it's small, it's a 36, it's very small, and you have this flag set at here. Specifically, this flag, it means that you need to decode the streaming. That's the necessity. You need to decode this specifically object, okay? And object 12, we have another reference, object 13. In object 13, we have a new streaming. And take a look at the left. In this case, is too high when you compare with the first, okay? So we need to analyze this specific object because the size, the left is bigger when you compare with another. So maybe this is the main object to analyze, okay? So nice. The first is I was executing the PDF TK to manipulate some information inside of the PDF. We have many functions to use in here, but my idea in this case is basically to using to uncompress information, as you can see here. I can use it to compress or uncompress, or even if you'd like to merge some PDF, I can try, but in this case, in this investigation, I'm using to uncompress information. So first of all, set the PDF TK to request some output, because the idea is to, to collect this information, to copy this output and pass in this specifically done doc text and executing the uncompressed information. Because remember, my idea is to uncompress the streaming, okay, and object 13. So let's read what I found here and bow. So here is the first technique used by the attacker. As you can see here, you can find the JavaScript obfuscated. So the next step is what? Obfuscate this specifically code, right? Remember, this is JavaScript obfuscated. As you can see here, we can see some standard information like a number, letters, %. So I created this specifically sample doc.html. And after that, I will see some, again, the standard, as I mentioned, number, letters, and parameter. I see the evil parameter, and I thought, so I am in the web application environment. No, I thought I have a JavaScript. So sometimes the JavaScript is totally linked to some web applications. So my idea now is to try to using this evil parameter to try, I made some tests, but I just put in here the test, the specifically end of the test. I put in the document right, because my idea is to print these informations in some web applications. Because of that, I'm using the script tag using the HTML and using the document right here specifically, as you can see here. So after that, I save this specifically file, right? And I have now the sample doc.html, and I can call this specific file in the web page, okay? And I give the permission to execute this itself, right? And after that, I call the browser to request, not request, to call this specifically file, right? To read what kind of information I have inside of that, okay? And take a look what happened now. I can find the payload, right? The payload is basically is the package responsible to download the victim machine, and this payload is responsible to call back to the CNC, and in this case, a command and controller, okay? So this is the package responsible to give the access to the attacker, okay? So then these steps I could finish the analysis, but I continue to analyze. And after that, I have some standard information, as you can see here, and I generate a real payload, because my idea here is to collect more information inside of this standard, as you can see here. So take a look at what I found here. So if you see here, I found here the standard, some standard, as you can see here, the percent, PDF, and something ladder number. So we have here some interesting information. It's based on UC2 encoding technique. That's another technique used by the attacker, right? So I will extract, as I can show you here, I extract the percent PDF, the percent I use inside to cut all those percent. And here is the encode used by the attack. Another technique, encode based on UC2, okay? It's based on the evolution of this is UTF-32, okay? And let me go through the Windows environment, because I perform this in the Windows, in the Linux environment, and I executing this in the Windows environment. Oh, actually in Linux and in Windows, using both of them, okay? Just to show you. So this is the same package. In this case, I will using the Windows platform just to show you. I will pass here in this specifically tool called Mozilla, okay? And I will pass here. Remember, in the Linux platform, I'm using sed, okay, to cut this percent. But in this case, I'm using Mozilla, the same case, to generate a UCS2. Sorry for that. The name correct is UCS2. But basically, it's in 2 bytes different. I generate the exa file, as you can see here. And I call this binary has a CNC, okay? It's because remember, I have here the payload. Remember, I have a JavaScript obfuscated. This JavaScript obfuscated download on the victim machine a payload, and this payload is responsible to call back the attacker, right? And this specifically callback is using a UCS2 encoding technique to hide the information inside of that. What kind of information that you using to hiding here in this case? So I am using another tool from the Steven. In this case, it's a short search to find what kind of information I have inside of this specifically binary, okay? And I request here the protocol HTTP, and take a look what I found here, the IP address from the attacker. This is the IP address responsible from these attacks, as you can see here. So now we found the CNC from the attacker. And where is the place in this case? In Europe, in a specific place or country. In this case is Estonia, okay? And here, as you can see, I finished the investigation. So we can see here more information about that in the Aristotle to try and find all those informations. And I finish here my presentations, right? So here's some books. Usually the people ask me about what kind of book they can use to start the studies about the malware analysis. You can use in the mastering malware analysis from Peck or malware techniques. If you like to work with a threat hunting, you can work with these specifically books about the hunting. And I finish these presentations, and I just say thank you for being here with me during these presentations again, my contact once again, and I finish here my presentations, everyone. If you have, I don't know, any questions, so please let me know.